Should we give folks a few more minutes? Rifat, what do you
Yeah,
think?
yeah, I think so. Maybe one more minute, and then we'll get going here.
Hey, Deb, good to see you.
I have to find my mute button. It's nice to see you too. Well, sort of see.
Yeah. And for what it's worth, it's also great to see the other participants in the call. So
Yeah. Okay.
It's nice to be participating in a friendly working group. Just saying.
Yeah.
Thanks.
Who would think it could be different, right?
No, thank you. You can leave the other working groups as they are, not here, please.
We should invite some people from other groups.
Peter, are you saying something? Because we couldn't hear you.
Oh, no, I was just going. Okay. I was just reflecting that the meeting is being recorded. I see. So.
I see. Yeah. Okay. Did I see George here? Where is George? I don't see him. Right. I think he's going to be presenting first. Maybe not. Okay. If not, Brian, sorry, Brian. Peter, you might want to go first if I don't see George here. Okay.
That's fine.
Okay. So let's get going, everyone. Hey, thank you all for joining. First, thanks, Hannes, for taking notes. It would be great if somebody else can help Hannes and with taking notes. That would be great. So let's get going. The not well applies here. This governs everything that we do at IETF. So please, if you're not familiar with this, make sure you get familiar with this. This is important. That not really well is to remind everyone that to be really respectful and professional during discussion, collaboration. We don't tolerate hostility and intimidation here. And we hope we can get a really good discussion today, respectfully. That for today we have two topics: transaction token and identity chaining. That will conclude that two sessions for December. We will have a break of 2 weeks for holidays, and then we'll restart again in January. So that's our agenda for today. Any questions, comments? And I don't see George here. George, are you here? No. Okay, I'm gonna stop sharing and I'll let Peter then go first.
Thank you, Rafat. Can you give me control or allow? Can you put my slides up or something like that? Yeah.
Here you go. I gave you control. Should be able to share.
There we go. Okay. So if you're interested in the OAuth identity and authorization training across domains topic, you are in the right meeting. I'm Peter Castleman, and those are my co-conspirators for this draft. Get next. There we go. So quickly, we'll do a quick recap, just as a reminder on what the identity and authorization training draft is trying to accomplish. And then the main topic for discussion today is really around sender constraining tokens. It's a feature that we have been looking to add to the specification. And as we've sort of been working through that, we've sort of learned a few things, and Kelly will share more specifically on that topic. And then finally, there will be some opportunity or request for some wisdom from the working group on potential ways in which we can move forward. Okay, so why do we need identity chaining across trust domains? So this is a very typical kind of model where we would have, a set of services in one trust domain, which is composed in itself of various microservices, who then need to access another resource provider or another resource server in another trust domain. So in this case, foo being one of those microservices, trying to access a gateway in another trust domain to complete a call. And a typical example of this might be something like an HR system that needs to update payment information or payroll information in a different system that maybe that lives in the finance domain, for example. And so the desirable thing is that we want to preserve the authorization and identity context from trust domain A and have that go to trust domain B, so that it is available for authorization, decision-making, and audit purposes. So good news, there's some already existing RFCs that we can use to sort of define and describe how to cross these trust boundaries using RFC 8693, token exchange, and RFC 5223, which is about the authentication and authorization grants. And so roughly the flow here is that a client in domain A might have a token, maybe an access token, or some other token presented to the authorization server in domain A, get an authorization grant to access a trust domain B, and then use that authorization grant to request an access token from the authorization server in trust domain B, and upon receiving this access token, can merely use that with an authorization, with a resource service in trust domain B. So that's kind of the protocols. And then the other thing that we make provision for is that in order to preserve some context, the authorization servers, which are trusted, can transcribe some of these claims. They can augment claims. They can also redact claims, right? So they can decide that some information doesn't need to be passed along. And all of that can be driven by policy. So there's some allowance for claims being transcribed. And so back to our diagram, how would this work? So there would be a client in trust domain A, call authorization server in domain A, do token exchange, get that authorization grant, present it to the authorization server in domain B, get back an access token, and then use the access token to access a resource in domain B. So that's pretty straightforward. And then there's two use cases that we've identified or that sort of led us to this point. One of them is where there is a resource server, which now acts as a client towards the authorization server. So it may have received a token, a transaction token, an access token, and now it acts as a client to get an authorization grant. And then it continues to act as a client to obtain an access token, and then it uses that again as a client towards a gateway. So all of that pretty straightforward. And then there's a second use case, and this is where the client itself or the service foo is not allowed to directly talk to the authorization server in domain B. And so in that case, the client or the service resource provider foo might request a token from the authorization server in domain A, which then really sort of performs this cross-identity protocol. It would issue a authorization grant to itself, request an access token, retrieve the access token, and pass that back. So in this case, we do not define the interaction between foo and authorization server in domain A, but the authorization server in domain A can use the specifications in this document to obtain an access token on behalf or as a proxy for foo. So that's sort of the second use case. So what's in the draft? So in the main section, the normative section, we talk really about the main actors, the client in domain A, and its interaction with the authorization servers in domain A and B, as well as accessing the resource in domain B. And then there are really the two use cases in the appendix, sort of non-normative, really describing how you would fulfill the use case or how the flows that we define in the main document would be applied or would be used. to fulfill these use cases. So all of that, I think, sort of nothing new there. I think that's been around for a while. And so then the question around sender constraining tokens. So when we look at the main flow, essentially at some point, the client in domain A will interact with the authorization server in domain B. And so when that happens, we can use something like MTLS or DPOP to constrain the tokens between the client in domain A and the authorization server in domain B. And similarly, for use case 1, whether that resource server acts as the client, it will interact directly with the authorization server in domain B. And so again, MTLS and DPOP sort of points us to an obvious direction for describing how to sender constraint tokens. When we look at the authorization server as client, because the authorization server is now sort of acting as a proxy between the resource server that would end up using the access token, or the client that would be using this access token, and the authorization server in domain B, there is no sort of defined way, at least as far as we can tell today, that we can just point to and reuse. So MTLS and DPOP sort of assumes an interaction between whoever is requesting the access token and the authorization server. And so that, with that proxy in the middle, that's not necessarily possible. And so this is sort of following out of the IETF 121 discussions. One question that came up is, do we actually need a new sort of delegated key binding mechanism to handle this kind of binding through proxy? And so to talk a little bit more about that, Kelly, I'm going to hand over to you. Is there a way easily, Rafat, for me to give control to Kelly?
Would you keep control, Peter? I don't know that I have the ability to share with my laptops. Can I just keep you sharing?
You can just tell me to click and I'll click.
Thank you. I appreciate it.
Okay, before we move on here, you have 2 people in the queue. Do you want to take comments, questions now?
Sure, Brian.
Brian.
Yeah, sorry, can you hear me? You just mentioned this was, some of this was coming out of the discussions at the last IETF, and I wanted to note for everyone else present that a lot of those discussions actually happen in the hallways after and around the meetings. So I'm not sure everyone is a party to the context that you provided there. It was sort of driven around confusion from the presentation and the actual meeting, but then there were a lot of offline conversations around it. So you may want to just have that context for everyone.
Thanks, Brian. So maybe I can, and to Brian's point, following the presentation, we did end up having various conversations in the hallways. And I think one of the conclusions we came to is what Kelly is going to share today as to a potential direction forward. Thank you, Brian. Hannes?
Yeah, I think I agree with Brian. This was an important sort of note. I was also wondering whether you had 2 use cases, and in those, so the question for me is, do you actually need those 2 use cases? Because in other solutions that offer that functionality, those 2 solutions, there only is one solution. And so now the question is, like, could you reduce it to make it less complicated?
So Hannes, you broke up. Can you maybe just restate the question? Okay.
You assume that there are 2 use cases. You called it use cases. I call it solutions, design solutions. And I'm wondering whether you really want to have 2 solutions, 2 different alternatives.
Yeah, I mean, we think of those as use cases that we would like to satisfy or like to use the specification for. And I think as Kelly sort of walks through this, maybe it'll become more clear about why that might be useful. But it's a good question, whether we should have those use cases at all, and then leave it for profiles. For example, I think Aaron has a document that is profiling this for a very different use case, right? And that is another path that we could discuss as well.
Yeah, and I'd like to add that in the two use cases, there are different mechanisms involved when the resource server is acting as the client. It's more or less straightforward and uses existing mechanisms, whereas when the authorization server is acting as the client, it's more complicated, and I'll talk about that here in just a second.
Okay, let's go.
All right, so going back to the previous slide, Peter mentioned that the client, when the authorization server, when the client in domain A can't access the authorization server, this causes a problem, right? So this is fine when the resource server is acting as the client, because it can directly connect to an authorization server. But what if it can't? And here are a few reasons that we call out in the draft for why the client may not be able to connect to the authorization server, may not have knowledge or network access. The case that my customers and it requires is that there's strict access controls on resources and which clients are allowed to connect to the authorization server. And additionally, the authorization server requires some sort of authentication that the client cannot provide. So those are the reasons why the client may not be able to access the authorization server. And Peter, if you'll go to the next slide. So if there's not a direct connection between the client and the authorization server, we're going to propose that there is a proxy that does have access to the authorization server. So the client, instead of requesting a token from the authorization server, it goes through this proxy, and this is good in some ways and causes problems in some ways. So next slide, Peter, please. All right, so this leads us to delegated center constraining of tokens or delegated key binding. And in this case, so just following sort of quickly through the steps here, the client requests an access token that it can use to access the resource server. And so it's going through the proxy, which then sends a request, an authorization grant in our document, but sends a request to the authorization server and asks, please include the CNF of the client, the value to validate the proof of possession. Please include this CNF in the return token. And this is where a little bit of, this is where it gets interesting, and this is where the use cases sort of diverge. We don't need this when the resource server is acting as the client. So this proxy requests a token with authorization grant in a draft, and says, please include the CNF of the client in the return token. And the authorization server abides by this request and does return a token that contains the CNF of the client. And this is different from what should happen in this case. So the proxy is essentially acting as an OAuth client and makes a request, and the returned CNF should be the value for the proxy. But here we need it to be the access or the CNF value for the client, because the client is the one presenting the token to the resource server. And so when the resource server validates that proof of possession, it needs to have the CNF claim of the client, not the proxy. And we have a couple of things to point out. The first is that from the client's point of view, both the proxy and the authorization server in this oval appears as one to the client, because in step A, it requests a token, and in step D, it gets a token, right? So it doesn't care what happens behind the scenes. So some other sort of details are noted at the bottom of the slide. This does require some sort of trust relationship between the proxy and the authorization server, because the authorization server needs to trust that the proxy has validated the proof of possession, and also that when it requests the token that contains the CNF of the client, that involves some sort of trust relationship between the two. What else? I think that's all for this slide. So next slide, please, Peter. And so going back to Peter's definition of use case 1 and use case 2, where use case 1 is when the resource server is acting as the client. This is use case 2 in our identity chaining draft, where the authorization server is acting as the client. So this gets more specific. Before, we just called it a proxy and gave a high-level description of what's happening. Here, we specify, well, okay, what if the authorization server in domain A, we got 2 domains here now. This is what we've been talking about in the identity chaining draft. And we're talking about authorization identity chaining across domains. And so in this case, everything happens just as before. In step B, when the authorization server in A requests the token from authorization B, it says, please include the CNF value of the client, which authorization server does. Authorization server B does, because there is some sort of trust relationship. And please excuse the audience claim that shouldn't be there. In my customer's use case, it will be included there, but it's not in the draft. It won't be required. So, pay no attention to the man behind the curtain there. And I think, let me give you a second to sort of parse and process this slide. And the question, one of the questions that we have, the last slide we have poses a series of questions, and one is we talked with Aaron, and from an implementation point of view, do we want to specify what happens inside this oval, or leave it as implementation details? So that's the main question that comes out of this document, this picture. Yeah, Hannes, go ahead.
Well, I would be very surprised if you don't specify that, because ultimately, this is interdomain between different servers. Likelihood that they are operated by the same party are close to 0, right? So I would expect that there is some interoperability guidance, at least.
Right. So
Yeah.
one of the things that we sort of tossed around is whether to include it as in the body of the document as normative language, or include it in the appendix where the use cases are described in detail, and leave it as non-normative. So those are 2 options for including it in the ID chaining draft in terms of how to specify the protocol between authorization server A and authorization server B.
Yeah, sorry, I'm in the queue here, so
Yeah, go ahead, Rifat.
I agree with Hannes. Like you can't just leave it to implementers here. Like you need to be able to specify it clearly, whether in this draft or a completely different draft. That's a different discussion, or a different
Right. Yeah.
question,
That's
I
one of the
guess.
questions we have for you. Yeah.
Okay. Yeah, but like you can't leave it just wide open. Right?
Okay. Thank you.
Okay, Kelly, should we talk about the fact that there are other sort of similar applications emerging that we're beginning to see as well for this delegated type model?
Yeah, Peter, if you would go ahead and take back over and talk to this slide, which I think you have more information and background and knowledge of.
Okay. So one of the interesting things that we've, as we've sort of been working through this, one of the things that's emerging is this idea that there are other use cases where the client that's being credentialed or the client that isn't necessarily talking to the authorization server or to the identity provider directly. There's some kind of platform proxy. So, for example, something like Istio ambient mode sort of has that. And again, the need for interoperability then starts coming up because these become very distinct concepts that is provided by different technology providers. And so again, it's a similar sort of model of there's a platform proxy in the middle that is acting as a proxy between the identity provider and the workload. And right now it's primarily around credentialing or provisioning sort of, let's call it bootstrap credentials, but that could very easily extend to this sort of delegated key binding type concept as well. And so the questions, as Kelly pointed out, that we had is, right, one, should we be looking to support all of these use cases? Should we limit it to talk only about the flow, the main flow and the RSS client, or should we actually just leave sender constraining tokens out of this draft and leave that as sort of an exercise for future profiles? And then on the delegated key binding side of things, questions that's come up is, should it be left as an implementation detail? I think already from Hannes and Rafat, we got some good steer there. And then the other question is, should it be in this draft or should it be done in a separate draft, right? And all of this, depending on which way we go with that, could sort of define some of the scope of the document, right? What we include and what we don't include. So that's kind of some of the background and the questions that we're hoping to get some feedback on.
Okay. Thanks, Peter. Thanks, Kelly. Any thoughts from anybody?
Yeah, I know this is a hard problem that may take some sort of in-depth thinking about. And so we appreciate any feedback now or even later once you've had a chance to think about it and review the document.
I'm curious, Hannes, you had a comment earlier about, do you think this is something we should include? My question for you, your thoughts, is this something that you think is in the scope of this draft to define, or do you think this is something we should be defining elsewhere?
Good question, Peter. Yeah, I think you raised a number, or you both raised a number of tough questions for the group to think about. I think it probably needs a few cycles to find, or some spare cycles to find out what the story here is. I'm still wondering about the delegate or this proxy use. That's something that is not necessarily something I was hoping to hear in some sense, because it makes things complicated after all.
Yeah, I agree with you, Hannes. When the resource server is acting as the client, it's very straightforward, uses existing mechanisms. But Peter mentioned a use case, and my customer has a use case where, for example, the resource server in one domain maybe isn't even allowed access to an authorization server in a different domain. So that would be a concern of mine if we did move this into a different document, that there wouldn't be a whole lot of support out there for it, because as you mentioned, it's maybe not typical.
Yeah, but I still want to, like, in terms of, like, on one hand we have the whole industry moving to this, or at least entertaining the ideas of the zero trust, and then you still have these gateways in between, sort of making sort of this end-to-end security somewhat complicated. But I guess that's just reality, right?
It's also a trade-off around efficiencies, Hannes, and I think it's actually something that's coming up. It's a topic in the Cloud Native Compute Foundation, things like SPIFFE. This is coming up as there's efficiency reasons for why those proxies sit there, or is sort of involved in this negotiation, and it's an interesting question about how do you secure that, right?
Okay.
Okay.
And go ahead, Peter. You wanna kind of wrap it up then?
Okay. So I think generally, Hannes, thanks for your insight around the need for defining such a thing. If your observations about why it's needed, I think is valid. I think we have some. I think what we want to do next is potentially go and sort of rethink a little bit about how we might talk about this as we describe the use cases, and I think and then maybe come back with a proposal by the time we get back together in Bangkok about how we might proceed.
Thanks in any case for sort of precisely framing the questions that the group has to think about, and so go back to the companies and co-workers to sort of figure out what they actually want.
And for what it's worth, I'm hoping to attend the OAuth security workshop in Iceland in a couple of months, and if I'm able to go, those there would hopefully have a chance to read through this and provide some more comments and feedback.
Yeah, but keep in mind that the OAuth security workshop is sort of like not an official group meeting. So any discussion that happens there is something that we need to channel back to the working group and on a mailing list to provide to fill in the context for others.
Yeah, I was just trying to point out that might be, since we're not getting a whole lot of feedback today other than from you and Rifat, that it might give people some time to look at it and give some feedback, which we could then take to the mailing list.
Okay, awesome. Thank you, Peter. Thank you, Kelly. That's good. Let's switch gears. Okay. Is George here?
I'm here.
George, yes. Thanks, George. I think you should be able to share slides yourself, right? So you want to try that?
Let me
hold on.
I do not have them handy on this computer, but I can go get them.
No. You don't have to, like, you can go to the bottom
Okay.
of the screen there, and the hand with sorry, there is a button called slide, share slides.
I see one that says ask slides.
Ask slide.
The only one I have at the bottom says ask slides and stop slides.
So there's 3 little dots.
No, he doesn't need to go to the 3 dots. You see the hand, join the queue, the one to the left of it. You should be able to share slides.
It says ask slides.
Ask slides. Okay.
His might be different because he's not a.
There you go. Now, try now.
Yeah, I see one, and so do I just pick the one?
Yes.
Okay.
There you go.
Okay.
You try now.
All right. First time to do that. You guys have always driven for me. But this is good. All right. So transaction tokens. We just had a couple of things for those on the mailing list. I hope you saw the email from Atul talking about sort of 2 core issues, and those are the ones that we're sort of bringing forward today. Okay. So a little bit of background about transaction tokens. The core aspect of transaction tokens is to have a token that lives for the lifetime of the transaction as it traverses multiple backend workloads or microservices, as described in this diagram. And the reason for that is that oftentimes in backend deployments, you will do client authentication between point to point, but not across the entire aspect of the transaction, which means compromise of an intermediate service often allows for manipulation of parameters of APIs, invocation of APIs with changing out who the user is and things of that nature. So there's a sort of a security aspect of transaction tokens, reducing the attack surface from a zero trust perspective. Generally, in the simplest case, from a description perspective, you know, a request could come in, let's say, to an API gateway. You know, with an OAuth token, the API gateway can use the transaction token service to exchange that OAuth token for a transaction token. And then basically the transaction token is very short-lived and can be passed from one microservice to another microservice through the back end. There are some additional benefits you get out of this. Transaction tokens have a unique ID, which can give you some understanding of the flow of transactions within your back end. You can, of course, do that with other mechanisms like OTel. You know, if you are looking at just the sort of flow, transaction flow perspective. It also gives you the ability to make certain aspects of, let's say, an API that's received at the API gateway immutable. So you could, you know, if the API gateway is trying to add a user to, you know, a group chat service, you can put both the user and the destination group chat into the basically what we're now calling the transaction context, and then effectively make them immutable across all the backend workloads, which, you know, helps protect against someone trying to swap out parameters. There's also the ability in the OAuth context to downscope a request, right? The purpose of a transaction token can be much finer grained than what's commonly in an OAuth token. So that's sort of go ahead.
Sorry, George. Peter, can you please go mute? Keep going, George. Sorry.
Okay, so that's kind of the background. I'm happy to pause briefly if anybody has any like major questions, but I just wanted to sort of like, you know, level set us all on what transaction tokens are. There are a couple of, you know, different contexts, right? How do you invoke from one, and, you know, how do you use this if it's just an internal workload as opposed to one coming through an external endpoint, and we cover some of that in the spec as well. Today, however, we wanted to talk about, this has come up a couple of times, RAR and transaction tokens. There isn't any direct correlation or connection between RAR and transaction tokens. What sort of happened is in the first version of the deck, when we basically said, okay, here's sort of your context, you know, your additional authorization details will be, you know, labeled as AZD, and that sort of it's not a direct overloading of anything in RAR, but the term authorization details is fully spelled out as the JSON claim name for RAR. So, you know, that brought up questions about, you know, is this supposed to be just a RAR object? Is it something else? So when you request a transaction token, there's a request details JSON object that can be passed in. And then the resulting, you know, the transaction token service has the ability to look at that and, you know, apply rules about what data in there it thinks is relevant for the transaction token. And then there's what will become TCTX, because I haven't done the pull request yet. It's the change for that has started, but like I said, I haven't submitted the pull request yet. Those authorization, the request details from the transaction token request would appear here in the transaction token context. So I think the main question around here is, should we reference RAR at all in a non-normative way? Effectively saying that, you know, if you're leveraging RAR and you want to sort of like have a RAR object in your transaction token, then please put your authorization details claim at the top level of the, you know, the authorization details claim would be at the top level of the TCTX claim. Or you know, it's recommended that it goes there. Go ahead, Hannes.
I was just wondering what the benefit would be to use RAR. Would there be something that we would really benefit from, like in terms of like implementation, experience, the format, or anything?
So, I mean, it is possible that let's say in the external case, the OAuth token that comes in, the access token, actually has a RAR object in it. And while it wouldn't necessarily come into the transaction token service via the request details object or parameter, it is possible that it would make sense to take that RAR object and stick it in the transaction context, because in the potential of a RAR object that is one-time use, it would already probably have the critical elements immutable in a way that downstream systems understood. So I could see it happening. I don't know that there's a huge amount of value in, in sort of calling out RAR specifically, but because it's come up in multiple of our previous, conversations at the IETF meetings, we sort of wanted to drill down here on, what should we do from a spec perspective? We've taken the feedback. We're not going to use AZD as the claim name. And so we can just be completely silent on it, or, we could, put something somewhere that's, a little bit more non-normative. Or we could be normative, but I think that's even less useful.
Thanks.
Yeah, and if there's, there's no strong feeling one way or another, then we'll just, as editors will just decide and move forward.
Anybody else have any thoughts or strong opinion here? Doesn't look like it.
Hey, doesn't look like it. All right, maybe there's not, yeah. Okay, so the next topic, I'm not going to try and summarize the entire thread. I would, if you are interested in sort of like how transaction tokens and batch processing or stream processing might work, I highly recommend going and reading the entire thread. It is, or issue and set of comments. It is pretty long. But effectively, there are, real use cases where a transaction token that's short-lived for, a minute or whatever is not sufficient for the completion of the transaction. So this could be things like the user says, I want you to delete my account, right? And you've got to go to 50 different systems and ask them to delete the data and then collect all that stuff. And that's normally an async process. And legally you have 30 days to comply, or, whatever the number of days are. And so they don't tend to be like real-time processes. And so how do you sort of, leverage a transaction token in that kind of a context? Other use cases tend to be streaming cases. And the longer the lifetime, or the longer the transaction takes to complete, the more sort of issues you have to deal with, changing in the context. So one of the examples I think we talked about on the issue is if the user changes their consent, right, to some sort of use during the part of the transaction, when do you basically go back and find out that what you were trying to do is no longer allowed by the user? And what are those time windows for your particular use cases? So I think the discussion that's been had so far is the transaction token should stay short-lived, right? So if you pick it up off an async queue and now you need to do something, right? If you were to have a transaction, or, it's more about should there be another artifact that sort of gives the receiving service the right to go request a transaction token with some set of predefined constraints, so that it can use a short-lived transaction token for the bit of work that it needs to do. And then maybe it needs to, put another one of these right to request a transaction token, tokens onto, another stream that some other downstream system will pick up. So go ahead, Hannes.
I was just wondering what the implications are if we were to design that batch processing feature.
Well, I mean, the implications are that we would define a core, a mechanism that probably a lot of backends have, right? And they wouldn't be required to go, figure it out themselves.
I meant more like in terms of protocol behavior, is it more like kind of a refresh token mechanism, so you can ask for new transaction token over and over again, or is it more something that impacts the content, some new claims, the content of the token, or is it kind of I can now request multiple access tokens or transaction tokens in one go?
Yeah, probably not the latter. At least I don't think that's come up to sort of like have a way to say, hey, I need 3 different transaction tokens with 3 different audiences or something of that sort. The others, yes, kind of similar. It's probably similar something to a refresh token potentially. In reality, as soon as you pull in streaming, it's how do you do effectively, do we consider OAuth access tokens a good solution for an event-driven back-end architecture? And I'm not sure the answer to that question is yes. But fundamentally, if we defined a strong mechanism for dealing with authorization tokens in an async event-driven architecture, then whatever that was would work for the streaming case, right?
It seems that aren't Brian, I think Peter also saying leave this batch processing out of scope.
Awesome. Yeah, sorry, I didn't have the chat up.
Yeah, so like, do people have strong opinion of keeping it in scope at this point? And anybody? Like Hannes, go ahead.
Yeah, I was just wondering, like the scenario that George brought up previously, I don't think that's too unrealistic that you have a number of different transactions. For example, the delete case, the use of requesting something to be deleted, and it basically you have to run multiple sort of kind of scripts and interact with different systems. Doesn't sound too bizarre, right?
Right.
It's
The
not
question
something
is,
that we have never seen before. Like this is something from like 40 years ago, even systems had that requirement.
The question is, Hannes, whether to leave it in the context of this document, or should that be a completely different document that deals with that specific use case, right?
Yeah, I would move it in a different document if we just don't have the information now how it's supposed to work.
Yes. So some of the people have implemented some of this, right, in their own internal backend if you read through the issue. But that was generally our, the editor's sort of leaning as well, is to put, batch processing in its own specification, and work on it specifically. And then, hopefully there aren't, things that sort of break what the core specification has done. But that was generally the leaning. But it was, again, one of the things we wanted to raise here because it was, a critical issue, and we're trying to close out issues on the spec. So if the general agreement is, leave it out of scope of the core spec, and we can write another profile or specification to handle it as necessary, that's great feedback.
Okay, Brian.
I was going to channel Justin a little bit here. There's sort of two things going on with these. There's the transaction token itself, sort of the structure and definition of it. And there's the mechanism for obtaining the transaction token, which is using token exchange. And there's certainly a possibility, I think a good argument to treat these as two completely separate things. But I know the draft sort of has them both embedded, but I guess I just trying to bring in batch processing into it further conflates those two things and ties them together, I think, in ways that you all don't necessarily want to get into. So I just further rationale for keeping this stuff out of scope for the current work.
Great points, Brian, and I appreciate that. And I think that was, yes, I think that resonates well with sort of, some of our previous sort of like editors discussions as well. So we'll definitely do that. And, happy if we don't have an issue already to sort of look at the other. I worry about turning them into two separate specs because, in our world, we have so many specs that getting someone to implement something gets really complicated when you've got to tell them to go read 30 specs. But I also understand the value of separating out the sort of semantic construct or the abstract base class, if you want to think about it that way, of a transaction token, and then allowing for multiple manifestations, especially as it relates to whimsy. So happy for more feedback in that regard as well.
Okay,
Yeah,
Hannes.
the number of spec issue, that's always something that like we seem to have taken different stance on this over time. Sometimes more specs is better because it's more sort of tailored to a specific use case, and then we extended it again and so on and so on.
Yep.
But it's definitely something we want to keep in mind, George. We just don't know the answer yet. I think you pointed us to the issue on GitHub, and I think we should all be looking at this if you haven't done so. So definitely good material.
Thank you.
Okay. Thanks, Hannes. I don't know. Sorry, to pronounce that name, Cruz or something like this. Somebody's in the queue there. I'm not sure. You have any comment? No. Okay, he dropped. Okay. Nothing. Nobody in the queue, George. Anything else?
No, that was it for for today, and we got 7 minutes. So
okay, awesome, perfect. Anybody else? Anybody that has any comments on either of those documents? Okay, and don't see anybody rushing into the queue. Then I think we're good for today. I just want to remind you that we're not meeting for the next coming 2 weeks for the holidays, and we will meet again in January 6th. And for now, happy holidays to you all, and talk to you on January 6th.
Thanks, Rafat. Thanks, Hannes.
thank you.
Thank you. Take care. Bye-bye.
Bye, guys.